Hello everyone and welcome to day 2 of derivatives of graphs. We got the first example here. Find the maximum value of the function, the maximum value. Notice that this is the y value that we're looking at here. So f of x equals 8x minus x squared. So I'm going to take the derivative because that's going to tell me where the critical points occur. Critical points are where you have maximums or minimums. And so that's going to be 8 minus 2x. Set the derivative equal to 0. Which implies that x equals 4. Now, how do we know this? Well, I'm going to do a number line just to make sure that this is a maximum. And so plug in 8 minus 6 is a positive number. Plug in 5, we get a negative number, increasing, decreasing, and therefore we have a maximum. Now, this is where the maximum occurs. It is not the actual maximum value. So what I need to do is find f of 4. That's 8 times 4 minus 16, 32 minus 16, I'm going to get 16. That right there is our maximum value. Okay, and that happens at x equals 4. So you're given the 0.4 comma 16 if that's going to help you. Or f of 4 equals 16. Why is there not a minimum? Well, notice that we only have one critical value. We found that's maximum. It's also there's no minimum because we know this is a quadratic reflected. So we have quadratic usually looks like this. Instead, now it looks like this. So that's why there's no minimum value. Now in this case, it says find the absolute minimum and maximum for f of x over the specified interval. The difference here is, this just said find a maximum. This says find the absolute. This is the lowest or highest point that we've got. Now notice that the one thing that you are given here is an interval. And so there's two things that you need to do. One, find derivative. And then find critical point. And then, well, find critical points and value at critical point. And then find values at endpoints. The values being, in this case, -3 and x equals 1. Okay, so 1, find f prime of x. Which equals 3x squared, and f prime of x to equal 0, which implies that x equals 0, which then we know that f of 0 equals 0. So this is our first value. You don't need to test whether it's a maximum or minimum because we are actually given an interval. So we also need to find here, we also need to find f of -3, which equals -27, which is -3 cubed, and f of 1, which equals 1. So therefore, what is our absolute max? Well, our absolute max is our highest point, our largest y value. Well, that's at x equals 1, which is 1. So our absolute max, this is at x equals 1. So our absolute max is equal to 1. Our absolute min equals -27. And so the result is that this critical value had nothing to do with it in this case, but it can in some cases. So just so you guys know that. So whenever asked to find an absolute max or min, always follow these 3 steps. Moving on, just so you guys know, pause this and you can copy it down. We talked about this last video. So what we're going to do here is it's asking you that since we're given this is equal f prime of x. That's the key point. This is f prime of x. What we're going to do here is try to graph or give the information about the original function. So unlike last time where I gave you the original function, we had to draw the graph of the derivative. Now we're given the graph of the derivative, we have to find the original functions, or find the original characteristics of the original function. So we're looking for increasing and decreasing. This is where the derivative is positive and the derivative is negative. Concavity, we know that's the second derivative. Maximum and minimum points, critical points, and inflection points. Now, key thing here, and I talked about this in class a little bit last time, is the fact that we know nothing about the original function y values. We know nothing about that. All we know is the x values according to this graph. So, with this graph, if we look here, the derivatives are positive here and here. If the derivative is positive, what do we know about the original function? Well, if the derivative is positive, is greater than 0, we know that f of x is increasing. And so therefore we can say increasing, and I did not, so increasing from 0 to 3 and 4, 5, 6, 7, so 7 to 10. And we know we're decreasing in between there, 3 to 7. Because the derivative is negative. Any of these right there is negative, so therefore it's decreasing. So with this, we can also create a number line if we wanted to. 0, 3, 7, 10. And we know that we're positive, negative, positive. And so we can find that we have a maximum, a relative max, at x equals 3, and a relative min at x equals 7. And so the next thing that we can look for is concavity. And so we're going to be concave up. Sorry about that. Let's try again. Concave up where? Well, concavity is the second derivative. And so if we think about it, if we take this function and think of it as the original function, concavity would then be the first derivative. And when we think about that, the first derivative is based on whether it's increasing or decreasing. So we're concave up when the first derivative is increasing. And so we're concave up from 5 to 10. Remember that concavity is always open brackets. And we're concave down where we're decreasing 0 to 10. And with that, we now know that a point of inflection occurs at x equals 5. So again, concavity, when we look at a first derivative graph, okay, is based on where it's increasing or decreasing. So one of the things that I think may be helpful, and if you didn't understand what I was talking about last time, this may help you. This should all look familiar to you. Original graph, increasing, decreasing is where the first derivative is less than or greater than. Concavity, second derivative, less than or greater than. If this makes sense to you, you can pause it and move on. But one thing that I want you guys to look at is, what do we do when we're given the first derivative graph? So if I give you the first derivative graph, this is now f prime of x. If that's the case, if this is f prime of x, then this becomes f double prime of x. If that becomes f double prime of x, what does it tell you? Well, this information now moves this direction because we moved backwards. And therefore, that's why if we have an increasing function on the first derivative, we now know concavity is up because we've shifted over. Okay, so if the first derivative is this, the increasing tells us that the derivative after that is greater than 0. Well, that's greater than 0. Now we know concavity. So hopefully the idea that this shifts up here, that the increasing of the derivative tells us concavity, hopefully that will help you. Let's look at the next problem. Given the graph of the first derivative again, so this is f prime of x, We're going to find where it's increasing, decreasing, max and min values. Why don't you guys pause the video, do this yourself, and then I'll come back with the answers. So use the information we had before. And so what you see here should have been hopefully what you got. I'm trying to think. Notice that I put where the derivative equals 0, so the x-intercepts of a first derivative graph are the critical points. So we can just see that right off the bat here. A maximum or minimum, as we talked about before, is where the second derivative equals 0. And then one thing that I do need to state right here. I know in my previous example I wrote and. That is incorrect. You cannot be increasing at the same time. So the use of correct terminology should be here that increasing from negative infinity to negative 1 or from 5 to infinity. So just to correct myself and know that I did it wrong on the example before, you can go back and correct it. The next example, here we have the graph, a little more complicated. Again, pause the video, see if you have any questions, and I'll come back with the answers. Good luck. Turned it off. Here are the answers. I hope that it went well for you, and if it didn't, come ask me any questions in class. So the joke of the day applies to me a little bit. Why did the professor's lecture take so long? Well, he went off on a tangent. See you in class.